Hello my dear friends, welcome to our channel. So in the previous lecture, we started equations of motion under gravity and we discussed our first case. What's our first case? So whenever I am projecting my body in downward direction, whenever I am going to project my body in downward direction with some velocity u, it is going to hit the ground or it is going to strike the ground with some velocity v. Right? So as it is moving in the downward direction, as it is a body, as it is moving in the downward direction, so our gravity too will pull this object in downward direction. Not only I am just giving the velocity due to that it is going and striking the ground, it is also due to the acceleration due to the gravity. It is also due to the gravity which is pulling this object in downward direction. So as it is pulling this object in downward direction, that means the gravity is applying the force on this object and that force will be known as gravitational force. So as we are studying kinematics, we already told we have only 4 parameters. We will not discuss about the force acting upon the body. We will discuss only the motion. We will not discuss motion with the force. We will only discuss about the motion here. We will not discuss about anything about force. So as here gravitational force is present, even though the gravitational force is present, we will not discuss about the force, but we will speak about the acceleration. We will talk about acceleration. And what is the acceleration here? It is the acceleration due to the gravity. That is why we are calling it as g, and it is 9.8 meter per second square, and g is constant all over the earth. Right? So whenever I am going to leave this object, whenever I am going to leave this marker, it is going down. Why it is happening so? Because the gravity is pulling down. As I am holding this object is not able to move down even though the gravity is pulling down. Why it is not moving down, we will come to know while studying the laws of motion chapter. But in this chapter, we just have to understand whenever I am leaving this object is moving down. Why it is happening so? Because the gravity is pulling. So in this object is experiencing the gravitational force. But in this chapter we will not study about the force, because it is about kinematics, and kinematics is only about the motion, not about the force acting upon the object. So we will study only the motion. In the motion only 4 parameters are there: displacement, velocity, acceleration and time. We will not discuss about anything about force here. So that means it is experiencing force. In the force, you know the formula, F is equal to ma. That means whatever the maybe the force direction, that is only going to be the acceleration direction. Right? So you can see here it is a gravitational force. Gravitational force is pulling down. That means my force is in downward direction. That means my acceleration due to gravity is also going to be in downward direction, due to which it is in motion. I am not giving any force, I am not giving any velocity to this object. Even though I am not giving any velocity to this object, I am just leaving and it is falling freely. It is moving down. Why it is happening so? Because the gravity is pulling this object with an acceleration g is equal to 9.8 meter per second square. So the acceleration due to gravity is constant. So whenever we are leaving any object, that object is going to coming into motion with an acceleration of g is equal to 9.8 meter per second square, which is an acceleration due to gravity. So and we studied this in the previous class. As it is moving with the constant acceleration from here to here, the acceleration is not going to vary. Acceleration due to gravity is constant. We will take always an ideal solution. What we will take an ideal condition means we will take there will be no air present here, there will be no medium present here. We will consider it as a vacuum medium, and in 100% in your cases we will take only the vacuum medium. We will not consider air friction. It might be possible while studying the work energy and power chapter, we might take the air friction too if it is given in the question. But here it is a vacuum medium. In vacuum only we are doing everything. So whenever I am leaving any object, or whenever I am throwing or projecting the body in downward direction along with the initial velocity, it will also have the acceleration which is due to the gravity. G is equal to 9.8 meter per second square. And it is what we studied in the first case, equation of motion under gravity. That means we are going to study about the motion which is happening due to the gravity. So if I am also projecting downwards, there will be gravity will be present, the gravity will be pulling downwards, so it will come more faster. If I am not giving any initial velocity, even though it is going to fall, however, even though this marker is going to fall, however, but with some less velocity when compared to the previous case, and it is happening. So why it is, even though I am not applying any, I am not giving any initial velocity to this marker, even though I am not giving, it is moving down, it is falling down, because it is due to the gravity is pulling down, and it is happening so, and it is going to hit the ground or strike the ground with some velocity v, and my initial velocity will be 0 in that case, and the body which is falling freely under the gravity will be known as falling freely body. So we are studying only about the equations of motion under gravity. So the object which is in motion should have to experience the gravity, right? So in this case we studied. Now what I am doing is that I am just taking the reverse case. Whenever I am going to throw the object from the ground, that means I am going to throw this object, throw this ball or throw this marker with some velocity u, it is going to upward direction. It is going in upward direction. That means I am projecting the ball in vertically upward direction. Whenever I am projecting the ball in upward direction, what will happen? If my ball is going up with certain velocity, my ball is also experiencing the gravity in downward direction. You can see here, my ball is also experiencing the gravity due to downward direction. Whenever I am throwing the ball is going to experience the downward direction. Ball is going to experience the force in downward direction, ball is going to experience the gravity in downward direction, and it is going, and the acceleration, you can see here, it is in the negative y direction. That means it is in the downward direction. As I am saying, my gravitational force is in downward direction, that means my acceleration due to gravity is in downward direction. Right? So as my acceleration due to gravity is in downward direction, so as my ball is moving up, my velocity will get decrease, because my acceleration is in downward direction. As my acceleration is downward direction, it will go up to certain extent, and my velocity of the ball is going to be 0. That means whenever I am throwing my ball at a certain extent, you can see my ball will stop. So at an instantaneous time, at that instant, you can see the ball, for a while it will stop there, and then it will fall down again in downward direction. Why it is happening so? Because my acceleration due to gravity is in downward direction. Whenever I am throwing the ball is experiencing the gravity. My ball is experiencing the gravitational force. My acceleration is in downward direction. As my acceleration is in downward direction, the force is in downward direction. So the velocity which I have given to this body is losing that velocity simultaneously, and it is going to be 0 at some time, and after that this ball will fall down freely. This ball will fall down freely, and it will hit the ground with certain velocity. I can consider it as v dash. I'm considering it as v dash. So whenever I'm just throwing my ball, I'm just projecting my ball in upward direction. At some point it is going to be 0, as my acceleration due to gravity is acting in downward direction, and you just remember, acceleration due to gravity always acts in downward direction. Here there is no doubt, wherever you can throw the object, my acceleration due to gravity is going to act only in downward direction. That is why every object in this earth, you can see, every object will falls down only, will not go up. So what I am saying is that every object is going to experience only the gravitational force in downward direction. As the force is in downward direction, my acceleration due to gravity is also going to be in the downward direction. Here it is in the downward direction, due to which the ball is losing its velocity, and at certain point the velocity is going to be 0, where the ball is going to stop for a while, and then afterward it will repeat the motion once again, and it will come down. So it is starting with the initial velocity 0, as here v is 0, that means my initial velocity of this ball is going to be 0. I am considering my second situation. At the first situation, my ball will be having 0 velocity at the topmost point. After reaching the topmost point, this ball will come down to the surface of the earth, as you know already. So as this ball is continuing once again its motion due to the gravity, as my gravity is in downward direction. Now this ball is going to gain the velocity with the help of this acceleration due to gravity. So as it is moving down, it is regaining its velocity, and it is going to hit the ground with the certain velocity, which I am considering it as v dash, and it is u dash. So now we are going to see, and now we are going to derive the equation for this motion. Now we are going to derive it for the equation for this motion. For this motion, we will take first the first situation, and then I will tell you about the second situation, and it will be equal to or similar to the freely falling body. We'll study now, but before that we will take the first situation. I'm just projecting my body in upward direction. I'm just projecting my body in vertically upward direction. So as I'm projecting my body, it is going to experience the acceleration. As you can see here, everywhere my acceleration is in downward direction, and it is acceleration due to gravity G is equal to 9.8 meter per second square, and here too it is 9.8 meter per second square. As my acceleration is constant, I can use the kinematic equations. As my acceleration due to gravity is constant, I can use the kinematic equations. You can see here what are those kinematic equations. I have 4 kinematic equations. V is equal to u plus at, S is equal to ut plus half at square, v square is equal to u square plus 2as, and s is equal to v plus u upon 2 into t. These are the 4 kinematic equations which we studied in our first lecture while studying the kinematics. So in this lecture, by using these 4 kinematic equations, I am going to derive the equation for this motion. Why I am using these 4 kinematic equations? What is the reason for it? I can use these kinematic equations whenever my acceleration is going to be constant. If my acceleration is constant in horizontal direction, then also I can apply this kinematic equation. If my acceleration is constant in vertical direction, then also I can use my kinematic equations. So here, as my acceleration is constant, I am using the kinematic equations to derive the equation for this motion. Right? So I'm considering this as my first situation. I'm going to write first kinematic equation. V is equal to u plus at. What is the velocity? We should have to consider the direction too. Velocity is in upward direction. You can see here, velocity is in upward direction. I'm not going to write as 0 meter per second or anything else. Why I'm not writing means, it might be the velocity at any time t seconds. It is not the full time, how much time it is taking so that my velocity of this ball is going to be 0. It is like at what time the ball is having some velocity. So it is the velocity at a time t seconds. For example, if my ball is here, after t is equal to 2 seconds, if my ball is here, how much velocity this ball is having? They might ask like this. So instead of v is equal to 0, I am considering it as v here, because it might be v. It is going to move with some velocity. So I am considering it as v. So I am going to find out the velocity at a time t seconds. Even though it is going to the topmost point, after deriving the equation of motion for this motion, vertically upward motion, we can use v is equal to 0. No need to here use v is equal to 0. If it is in the question, if you know the kinematic equation, you don't need the formula. You can also use you can use this formula. By using this formula, you can substitute 0 and you can find out the answer. But you want the formula for this equation of motion, we should not have to put here 0. So v is equal to, it is positive as it is moving in the upward direction. It will be positive. You can see here, if I am asking you what is the velocity here, that means it is in the upward direction. My velocity is in upward direction, that means it is v is equal to u also in upward direction. I am applying the velocity in upward direction. I am giving the velocity to the ball in upward direction, so it is u, and it is minus g. Why I wrote here minus g? Because my acceleration due to gravity is in downward direction, so it is minus g and into t. So v is equal to u minus gt is my first equation for this motion. So v is equal to u minus gt. Second equation, s is equal to ut plus half at square. So as you can see here, S. So instead of S, I am considering it as H. I am considering it as H. So you can see the displacement. It is my initial position and it is my final position. It is my initial position and it is my final position, as my displacement is from the bottom to the top. That means my displacement is in upward direction. My displacement is in upward direction. As it is in the upward direction, my sign will be positive. So it is positive H is equal to U. My U is positive. You can see here U is positive, V is positive, U is positive, V is positive, S is positive, and G is negative. So I wrote here all the signs. I just have to apply these signs here. So it is A is G, and it is negative. So it is minus G. So minus into plus is minus, U2 minus half GT square. So H is equal to UT minus half GT square is my second equation for this motion. My third equation, V square is equal to U square plus 2AS. So you can see here it is V square, it is positive. U square is also positive, minus 2 into G into H. My H is positive, but A is negative. As it is negative, minus into plus is minus. So I am writing here minus 2GH. So V square is equal to U square minus 2GH. And my fourth condition, S is equal to V plus U upon 2 into T. So you can see here S is H. H is equal to V plus U upon 2 into T. As my V and U are positive, I not change the sign. So I derived the equation of motion for this by using my kinematic equations, and I got these 4 formulas. So I'm just going to write these 4 formulas here by rubbing my kinematic equations. So what are those my 4 equations? V is equal to U minus GT, H is equal to UT minus half GT square, V square is equal to U square minus 2GH, and H is equal to V plus U upon 2 into T. So you can see here, so it is the equation of motion under gravity for my second case. So how I derived these formulas? By using my kinematic equations, as my acceleration due to gravity is constant, I found out the velocity at any time t seconds, the ball might be here, the ball might be here, it might be anywhere. So at a particular time, what will be the velocity of my ball is V is equal to U minus GT. At a particular time, what will be my height? H is equal to UT minus half GT square. So V square is equal to U square minus 2GH is my third equation for this motion, and my fourth equation is H is equal to V plus U upon 2 into T. So it is all my 4 equations. So now we are going to discuss very interesting questions on the basis of this equation of motion. Before that I will clear this one. As once it is reaching to the top where my velocity is going to be 0, it is going to act like a freely falling body. You can see here, now my velocity is 0. As my velocity is 0, even though the acceleration on the ball is there, still the gravity is pulling that ball in the downward direction. So once it is reaching to its topmost point where my velocity is going to be 0, after that also my gravity is there, and that gravity is helping this ball, to come down to the surface of the earth as it is pulling down. As it is pulling down, this ball is now going to move in the downward direction. As it is going to be moving in the downward direction, it is going to hit the ground or going to strike the ground with certain velocity. So it is regaining its velocity just due to the acceleration, which is acting in the downward direction, which is the gravity acceleration. So my velocity, you can see here, it is acting like a freely falling body. My initial velocity is 0. Here it is going to it is going to strike the ground with certain velocity. You can see here U is equal to 0. Whenever I am leaving the object, my U is 0, but after it is going to strike the ground, whenever I am leaving this object, this object is already experiencing the gravity pull. But as I am holding this one, it is unable to move down. But whenever I am leaving this duster, it is going down due to the gravity. Due to the gravity pull, it is going down. The same thing is happening here. Here too, the velocity is 0. after the velocity is becoming 0, it is going down and is going to hit the ground with certain velocity. So this situation is it's more likely to be freely falling body. So we can apply the equations for this situation of freely falling body very easily. So whatever the equations we got for the freely falling body, we can apply those equations for this situation, but we need only up to this extent. In certain questions they may ask this one, so I'm just saying you to add up these two equations so that you can get the answer. We'll study these two. Okay, so what I'm saying is that we should have to study now for this. So whenever I'm projecting my body, what are my equations which I'm getting? So here are those 4 equations which I'm getting whenever I'm projecting my body in upward direction, which is experiencing the gravity, due to which my velocity is going to be 0 at the topmost point. And now we are going to discuss a very interesting question. So if you're thinking it's very difficult to remember the formulas, no need to remember any formulas. You can easily do with the help of the kinematic equations. But you should have to remember, whenever we are applying the kinematic equations, we should have to remember that we should have to use the signs. If you know the formula sign, SI, and S signs. So if you know the formulas, then there will be no need of using any signs. So if you don't know the formulas, then you can use the kinematic equations too, and you can find the answers by using that kinematic equations. And we will do the same. We will do both. We will do first by using the kinematic equations, and then we will use by using a simple formula of those equations. So what is the first question is that you can see here. What is my first question in this? It is given in the book. I will say you the question. I will tell you the question and I will explain too. So it is AAPMT prelims 2005. AAPMT prelims 2005. So question is a ball is thrown vertically upward. It has a speed of 10 meters per second when it has reached 1/2 of its maximum height. It has a velocity of 10 meters per second when it reaches half of the maximum height. That means my body, I'm just giving some velocity to the body. It is reaching half of its maximum height. That means h by 2. Half of its maximum height means h by 2. It is reaching h by 2. They not given the information of this velocity. They told after attaining the height h by 2, it is moving with a velocity of 10 meters per second. I will repeat the question once again for you. A ball is thrown vertically upward, and throwing this ball in vertically upward direction. It has a speed of 10 meters per second. When it has reached 1/2 of its maximum height. That is, when it is reaching 1/2 of its maximum height, it has a velocity of 10 meters per second. So they were asking, how high does the ball rise? So whenever I am just throwing my ball, how much height it is attending, how much height it is going, where my velocity is going to be 0. At the topmost point my velocity is going to be 0. That means from the bottom to that point where my velocity is going to be 0 will be my maximum height. So it is asking about the maximum height. They are asking us about the maximum height, and now we are going to find out the same. You can see here we don't know the velocity, we don't know the u, but at certain point after attaining the h by 2 height, they are telling that this ball is having a velocity of v is equal to 10 meters per second. Alright, this ball is going to also experience the gravity in downward direction g. Now this ball, after some time, what will happen? This ball will go at the topmost point where the velocity of this ball is going to be 0. We know this one. How we know? After some time, as my acceleration is acting downwards, my velocity is going to decrease and going to be 0 at a certain point. Right? That is what I said. If it is h by 2, if it is at a height of h by 2, that means it is also h by 2. From here to here, it is also half height. So from this velocity, as this velocity is going to decrease and going to become 0, up to that it is covering half the distance of my maximum height. Now I know only these two things. My velocity is 0. My velocity is 0 at the topmost point, and my velocity is equal to 10 meter per second at a height of h by 2. So what I am considering it as, I am just going to use these two information to find out my maximum height. And how I am going to do is that you can see here, I am applying my kinematic equation. V square minus u square is equal to 2as. V square minus u square is equal to 2as. So what is V square here? I am just considering this case. I am considering this as my bottom, this as my bottom. So where I am projecting this body with a velocity of 10 meter per second, and it is going to be 0 at my topmost point, and my height given as h by 2. I am considering like this. So V square is 0, u square is 100. You can see here it is 100 is equal to 2 into minus g. It is in downward direction minus 10, and my s is h by 2. H max upon 2. That is maximum height upon 2. It is the maximum height and it is the half the height, right? So you can see here it is 10 square 100, minus cancel. So it is 2 tens are 20. It is 100. 25's 100. So h max is equal to 10 meters. H max is equal to 10 meters, and you can see here what I found. I have not found h max upon 2. I not found the h by 2. I found the maximum height reached by the body. I found the maximum height, and this is what our maximum height is. H. It is h by 2, it is h by 2. By just using a simple kinematic equation, I just applied the signs in this simple kinematic equation for this motion, and I found the maximum height is equal to 10 meter per 10 meter. You can see here, I found the maximum height as 10 meter, and it's a very simple question they asked in the AIPMT Prelims 2005. If you know the formulas too, it will be very easy. It's not a very difficult one. But there is no need of using any formulas for this type of questions, because if we know just kinematic equations, that's enough for solving this type of questions, for solving this type of motion equations. You just have to understand only one thing, and you just have to remember only one thing, that is kinematic equations. So what are those four kinematic equations? B square minus u square is equal to 2as, s is equal to ut plus half at square, b is equal to u plus at, and s is equal to v plus u upon 2 into t. These are the four kinematic equations you should have to remember, and then you should have to work hard. You should have to solve so many problems. After solving so many problems only, you will come to know how to deal the questions, how to tackle the questions. These were more important for the students of Neet and JEE, right? So we will discuss more questions in the next lecture. So keep working hard, move on. So don't, that means whatever the things you are having, finish it that day itself. Don't keep in bending, and support our channel. It's a most important. How much ever you are supporting, that much ever I will try hard. I will work hard for you to give you so many videos. And whatever the doubts you may have, you can ask me in the comment section. Whatever may be the doubts, or if you want some any other chapters too, you can ask me in the comment section. I will take as soon as I can. So just support our channel. If you like this video, then like it, comment it, subscribe it, and please share it with your friends too, my dear friends. So have a good day, and take care of everything. Take care of your studies too. And what I'm saying is that just keep working hard. Forget everything. Studies will give you success, and it will be, I think, and you will be one day at the topmost position where nobody can touch you. But for that, you should have to work hard. This only will give you the result. Nothing is going to give you any result. You have to work hard. You have to stand on your own legs. You have to understand, my dear friends. So please take care, buddy. Take care. Bye.